Welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about JFET Common Source amplifiers. So let's see the introduction to this topic. So JFET is the Junction Field-Effect Transistor and the construction of the JFET is shown in this diagram. So it consists of three terminals: gate terminal, drain terminal and source terminal. So drain to source is the N channel or P channel, and gate is the p-type terminal in this diagram. So JFET is the voltage control device. So generally we can differentiate the BJT and FET based on this behavior, that when BJT is operating on the base current, it is the current control device, and JFET is the voltage control device. So gate to source voltage controls the drain current flowing through the drain to source terminal. So this is called as the voltage control device. So JFET amplifiers having the many advantages compared to transistor BJT amplifiers. So here in this diagram, JFET is used for amplifying a weak signal to a strong signal. Its amplitude is increased in this JFET amplifiers. So what is the advantage compared to BJT is it has high input impedance. So whenever we have a high input impedance, this amplifiers draws very small current from the source. So it provides low noise, good linearity, and it is a simple biasing method. So these are the advantages of the JFET amplifiers when we are using in for many applications. And what is JFET amplifier? So it amplifies the small signals, and it operates on the ohmic or saturation regions to provide amplification. And small change in the input signal gate to source voltage causes a larger change in the drain current, which is converted to larger output voltage across the load resistor. So it amplifies the signal very effectively. And let's see the common source configuration. So common source configuration, in this input signal is applied to the gate terminal and output is taken across the drain terminal. So source is common to both input and output. So it is analogous to the common emitter amplifier in BJT, where we get a high voltage gain and 180-degree phase shift between input and output due to the inverse of these input and output waveforms. So JFET common source amplifiers can be used as the voltage amplifier or power amplifiers. So this is a detailed circuit diagram of common source amplifier, in which voltage divider biasing circuit is used for biasing the FET, and input signal is applied through the coupling capacitor C1. So it is used to block the DC components from the signal and allows the AC signal to pass through the gate. And across the resistance RS we have the capacitor CS, which is the bypass capacitor. So biasing is provided by the potential divider network, and this equation for the gate voltage is given by the potential divider rule, which is R2 divided by R1 plus R2 into VDD. So suitable pair of resistor values in correct proportions produce the correct biasing voltage. And potential divider network, what is the advantage? So this gives the better stability compared to the fixed bias. So JFET amplifier provides better stability when we are using the voltage divider bias circuit. And bypass capacitor we have seen in this diagram, in the previous diagram. So it serves for the function of providing the good stability and prevent the reduction in the loss of voltage gain. So activity, identify the types of biasing in these three circuits. Here JFET is given in fixed bias, self bias and voltage divider bias configurations. And next we are going to see small signal analysis of JFET amplifier. So what is small signal analysis? Here we are going to analyze the behavior of JFET amplifier when small AC signal is applied. So here in this diagram we can see the equivalent circuit for n-channel JFET. Here VGS is the gate to source voltage and RD is the drain resistance. And small signal analysis of fixed bias JFET amplifier is given in this diagram. Here RG is connected at the source and RD is the drain resistance, and the drain resistance and transconductance values are used for equivalent circuit. So this circuit will be used to find the performance metrics like gain, input impedance and output impedance, and it is used to analyze and design the JFET bias amplifier circuit by the RF engineers. And let's see the applications of JFET amplifiers, like low noise amplifiers in audio equipment and radio receivers, and high impedance preamplifiers for sensor circuits, switching circuits, voltage control resistors, sample and hold constant current sources and oscillators. So these are the assessment questions. Thank you for listening this lecture.